All right, guys, well, welcome back. We are on section 4.5c today, U-Substitution with definite integrals. This lesson is not very long, but I do want to do quite a bit of review here in the beginning, so just so we all have a firm grasp before we start a few examples. All right, so hopefully you have a blank table with 8 rows, 2 columns. If not, you can create a table, do it on a page, a blank page that you can either rip out and put in the front of your composition notebook, just so it's easy to find, and not in the middle of all your notes, because this is, you're going to use this quite a bit. Okay, this is just review, so that I can make sure you have the derivatives memorized that you need to have memorized. All right. So there are 6 basic trig functions whose derivatives you need to know, and then 2 transcendentals whose derivatives I also want you to memorize. All right, so we're first going to start with the trig. In the left-hand column, we're going to write f of x, and in the right-hand column, we're going to write its derivative f prime of x. All right, so let's start with sine of x. Okay. All right, so we have sine of x. In the next row, I would like to do tangent of x. In the next row, I'd like to do secant of x. Okay. At this point, I would like for you to draw a line, because we're going to break up the rest of the functions of it. So just draw kind of a thick horizontal line there for me. All right, now I would like to write these 3 cofunctions, the cofunctions of these 3. So the cofunction of sine of x would be cosine of x. The cofunction of tangent of x would be cotangent of x. And the cofunction of secant of x would be cosecant of x, literally just adding the prefix co. All right, so now let's see how well you remember the derivatives of these guys. All right, so the derivative of sine of x is what? Hopefully we said cosine of x. Derivative of tangent of x, do you remember that? That is secant squared x. And then the derivative of secant of x is secant x times tangent x. Okay, so I'll give you a little bit of time to catch up here if you need it. Okay, once you have these 3 memorized, you really have the rest down already. Okay, it's very easy to convert from a function to its cofunction in terms of its derivative. So for cosine of x, go to sine of x. Okay, its derivative is here. Remember, all your cofunctions, all the functions that start with c, have a negative derivative. So you're going to start with the negative, and then switch to the cofunction. So the cofunction of cosine is sine. And that's the derivative of cosine. Cotangent, I know it's going to be negative. The derivative is going to be negative. Find the derivative for tangent and just change that to the cofunction. So again, just adding the prefix co. So the cofunction of secant is cosecant. All right, to find the derivative of cosecant, I know it's going to be negative. So find the derivative of secant and change all the functions to cofunctions. So cosecant x times cotangent x. Okay. All right, from there, I would like for you to draw a squiggly line. Those are your 6 basic trig functions and their derivatives. You must have those memorized. All right, the last two functions whose derivatives we need to know are your transcendentals with e as the base. So exponential function e to the x, that's Mrs. Peterson's favorite function, right? Favorite function because its derivative is itself, right? Yay. All right, who knows the last function I want you to have memorized? It should be natural log of x or ln of x. Its derivative is 1 over x. All right, so now you have a handy dandy little chart. So all these functions and their derivatives you need to know. And we also need to be able to go the other way around, right, for antiderivatives. So if I asked you, what's the antiderivative for cosine of x? Well, you could go to the right-hand column now and see, okay, well, what function has a derivative cosine x? Well, that would be sine x. Okay, if I asked you, what's the derivative of secant x tangent x? We'll go to the right-hand column, find secant x tangent x. Its antiderivative would be secant x. All right, so we need to be able to go both ways. Okay, so let's do a little bit more review on notation. So if I have integral of 1 over x dx, what does this mean? Well, this means find all antiderivatives of 1 over x, right? So this means, you may want to write this in your notes, this means find all antiderivatives of 1 over x. All right, in other words, this is equal to the natural log. So go to your chart, find 1 over x on the right-hand side, and the antiderivative of that is natural log of x, right? I do need to put absolute value bars here because we can't take the natural log of negative numbers. And what am I missing? I'm missing a plus c, right? Because I need to find all antiderivatives. Okay, what about this? What does this mean? This means find all antiderivatives of 1 over u, right? So the answer here would be the natural log of the absolute value of u plus c. Okay, remember the integral symbol along with the differential means find all antiderivatives of the stuff in between. All right, last example. I have the integral of 1 over w dw. All right, so the integral symbol along with the differential dw means find all antiderivatives of 1 over w. And so your answer here is the natural log of the absolute value of w plus c, right? The whole family of functions. All right, let's try a few more. This means find all antiderivatives of negative sine of x. All right, so look at the right-hand column. Find negative sine of x. The answer here then is cosine x plus c, all antiderivatives. How about this? This means find all antiderivatives of secant x tangent x. So in other words, what functions, when you derive them, your answer is secant x tangent x. Well, go to the right-hand column, and you'll see that the solution here is secant x plus c, right? When I differentiate this, I get this. Okay, last one. Integral of negative cosecant squared x dx. This means find all antiderivatives of negative cosecant squared x. So go to the right-hand side of your chart, find negative cosecant squared x, and we see that its antiderivative would be cotangent of x plus c, right? Okay, question. What if instead of negative cosecant squared x, this was positive cosecant squared x. How would your answer change here? Instead, you would just have a negative there, right? Remember, coefficients are not bothersome. Okay, how about what if I change this up a bit? What if I have this instead? So the only difference is now I have limits of integration. Now I have a definite integral instead of an indefinite integral. All right, now what does this mean? Now this means find the area under the curve of 1 over x from x equals 1 to x equals e. Right, and we learned last time that if I want to find the area under the curve, I can actually use an antiderivative, right? And that's from the fundamental theorem of calculus. So find an antiderivative of 1 over x. Any antiderivative is fine. So ln of the absolute value of x, right? And then fundamental theorem of calculus says, okay, you need to evaluate that at x equals e and x equals 1. So I have ln of the absolute value of e, which the absolute value of e is just e, minus ln of the absolute value of 1. All right, ln of e is 1, ln of 1 is 0, so my answer is 1. Okay. Let's do another review one. Now I want to find the area under the curve of sine of x from what kind of values are these? These are x values. So from x equals pi over 4 to x equals pi over 2. And how can I find this without a calculator? Well, I can find an antiderivative. So if you notice, sine of x isn't on the right-hand side of your chart, is it? But negative sine of x is. So you can just switch the signs. So an antiderivative for positive sine of x is going to be negative cosine x. Okay, and I want to evaluate that at x equals pi over 2 and x equals pi over 4. Always evaluate the top one first. Okay. All right, so I have negative cosine of pi over 2 minus a negative, so plus cosine of pi over 4. All right, pi over 2 radians is 90 degrees. So if I'm thinking about my unit circle, that is going to be up here. The ordered pair there is 0, 1. And remember, cosine is your x coordinate. So cosine of pi over 2 is 0. 0 is neither positive nor negative, so 0 there. For pi over 4, that is in the first quadrant, right in between the x and the y axis. This ordered pair then is square root of 2 over 2, comma square root of 2 over 2, right? So picking the x coordinate there, cosine of pi over 4 is going to be square root of 2 over 2. So my final answer is square root of 2 over 2. All right, so a bit, again, just review so far. Now I'd like to do a couple examples reviewing U-substitution. All right, so for this guy, go ahead and write this guy down in your notes. We have the integral of x squared times cosine of x cubed dx. All right, so what do you think I should let u be? Let's let u be x cubed, since the derivative of x cubed has an x squared in it, right? So u is x cubed, then du would be 3x squared dx. All right, and what do we want to do from there? Let's go ahead and multiply both sides by 1/3. Okay. I'm still going to highlight if you don't need to, and that's fine. I'm going to go ahead and keep highlighting here. So u is x cubed, so anywhere I see an x cubed, I'm going to highlight that yellow. And then I also want to highlight 1/3 du, which is x squared dx. So remember, if you want to rewrite the x squared by the dx, you sure can. All right, so now let's go ahead and rewrite this. So I have the integral. Let's try this. So I have the integral. Then I run into some blue, right, which is 1/3 du. So I'm going to put the 1/3 out in front, maybe. And the du always has to come at the end. Okay, always, always, always. All right, next I run into the cosine. That has not been highlighted out, so cosine. And then I run into some yellow, which is equivalent to u, right? Okay, so now we look at this integral. I want to find all antiderivatives of cosine of u, right? So look at your chart. The antiderivative or an antiderivative of cosine of u is sine of u. So that 1/3 is going to come along for the ride. I have 1/3 sine of u plus c, right? And what's my final step? I need to replace u with x cubed. So 1/3 sine of x cubed. And then again, a constant times a constant is still a constant. So just leave it as plus c. And that would be my final answer, right? In other words, if I differentiate that, I should get back to x squared times cosine of x cubed. All right, second example. Let's let ideas. What do you want u to be? Let's let u be e to the x. Then du, so go to the right side of your table, although this one is the best one ever, right? Because the left side. Derivative of e to the x is e to the x. So du is e to the x dx. All right, I'm going to grab my yellow highlighter. All right, now the question is the yellow part this e to the x or this e to the x? The yellow part is actually this e to the x, right? Because the blue is e to the x dx, right? Du needs to be at the end, and it needs to be by itself, right? Not in the denominator, not under a square root. It must stand alone. Okay, so e to the x dx is going to be this piece right here. That'll be my du. Okay, so let's rewrite our integral in terms of u. So I have the integral. Then I run into the blue, which I know is du, right? And that must come at the end. Okay, then I have the square root of some yellow, right? And the yellow is u, so square root of u, or let's just write it as u to the 1/2, yeah? All right, so if I want to find all antiderivatives of u to the 1/2, I would add 1 to the power, so that'd be u to the 3/2, and then divide by 3/2, which is the same as multiplying by 2/3, right? So I have 2/3 u to the 3/2 plus c. And my final step would be to plug u back in. So I have 2/3 e to the x to the 3/2 plus c. And that's my final answer. All right, so far that was all review. Yeah, so now let's look at the new stuff. All right, so now we're going to combine definite integrals with U-substitution. Okay, so let's talk about again, what does this mean? This means I want to find the area under the curve, right? And right now, what are these two values? These are x values, right? So just keep in mind when I change to u's here, I'm going to need to change the 0 and the 2 also. Okay, so let's start just like we did before. What would you like u to be? Let's let u be the stuff inside the square root, 4 minus x squared. Okay, that means du is going to be negative 2x dx. All right. Okay, so I'm going to grab my highlighter. So u is 4 minus x squared. And then negative 2x dx is going to be du, right? Okay. All right, so now we need to rewrite. However, here's my big caution, guys. Be sure you change these, okay, if it helps. And, you know, remind yourself that these are x values. Now I'm about to change to u, so I need to change those to u values. How would I do that? Well, I'm just going to go back to the yellow here. Okay, so when x is 0, plug 0 in for x here, what would u be? Well, u would be 4, correct? Okay, when x is 2, plug in 2 here, you would get 0 for u. All right. Okay, let's finish the integrand now. So next I run into some blue, which is just du. Remember that has to come at the end. And then I have square root of the yellow stuff. So square root of u, which again, I recommend writing as u to the 1/2. Okay, if you'd like, we can definitely change this improper integral to negative integral from 0 to 4. All right, but as long as you plug in the top number first, you're going to be fine. Okay, so you can change it if you'd like. It's not necessary. I'm just going to go ahead and keep going here. So we want to find the area under the curve of u to the 1/2 now, and these are my u values. Okay, so first we need to find a what? We need an antiderivative, which we know is going to be what? 2/3 u to the 3/2, right? Then I'm going to evaluate that at 0 and 4. Again, as long as you do the top number first, you'll be fine. All right, so if I plug in 0, well, 0 to any power is 0, and 0 times 2/3 is still 0. Minus, now we're going to plug in 4. All right, 4 to the 3/2. So first do the half or the square root. Square root of 4 is 2. 2 to the 3rd is 8. Right? So I have 2/3 times 8. Okay. Ooh. So my final answer is -16 thirds. Okay. What is something you notice? What are a couple of differences between definite and indefinite integrals for U-substitution? Well, hopefully you noticed, we did change the limits since we actually have numbers here. Another thing I want you to take note of is we did not have to substitute u back in, right? We never had to get this back in terms of x's, and that's because we changed these limits, okay? So make a note for yourself. You do not need to substitute u back in if you switch your limits. If you change your limits. Yeah? All right. Okay, let's try another example. Okay, this time I want to find the integral from, what are those values? From x equals 0 to x equals 1. Of this stuff. All right, do you see why we want to use substitution? First of all, we have like a baby and a mom, right? And also a form of the derivative of the baby is in here. Yeah. So what do you want u to be? Yeah, let's let u be x cubed plus 1. Then du is going to be 3x squared dx. I don't have that 3 anywhere, so let's go ahead and multiply both sides by 1/3. So 1/3 du is equal to x squared dx. All right, I'm going to go without the highlighter this time. So I have integral. We have to keep in mind that if we're changing to u's, these guys have to change also. Okay, so plug 0 in for x. What do you get for u? Well, you get 1. If you plug 1 in for x, 1 cubed plus 1 is 2, correct? Okay. Now let's see if we can do this without the highlights. All right, so x squared dx is right here, and that's 1/3 du, correct? So 1/3 is going to come out front. Du is always at the end. All right, then this part here, x cubed plus 1, was my u. So I have u to the 4th. Okay, a much simpler integral now. So now this is a definite integral, so I'm going to find an antiderivative of this guy and then plug in 2 and 1. So I have 1/3. Antiderivative of u to the 4th is u to the 5th over 5. And I want to plug in 2 and 1. All right, so I have 1/3, that just comes along for the ride. If I plug in 2 to the 5th is what? 32 over 5. And then minus, plug in 1 for u, you get 1 over 5, right? Okay, so I have 1/3 times 31 over 5. Um, 31 and 3 don't reduce, 31 and 5 don't reduce, so my final answer is 31 over 15. Okay. What about something like this, where my outer function is not explicitly defined? So I have the integral from, this is what kind of value? X equals 0 to x equals 2 of f of the quantity 2x dx. Now, if you wanted to differentiate this, what would you use? You'd use chain rule, right? It's differentiate the mom, f prime, hold the baby, of 2x, times the derivative of the baby, 2x, or 2, sorry. All right, so if I want to anti-differentiate, we would need U-substitution. Remember, that is anti-chain rule. So let u be the baby, let u be 2x, then du is going to be 2 dx. Right? I don't have that extra 2, so let's go ahead and multiply by 1/2. So 1/2 du is equal to just dx, or 1 dx. Right? Okay, now let's rewrite this. So a question I see on AP exams a lot, it may be something like this, and then ask you to rewrite in terms of u. All right, so I have the integral. This is usually multiple choice. If you forget to change these to u values, then you'll miss the points there. So make sure you change these to u. So when x is 0, u is 0, right? But when x is 2, plugging it back in right here, u is 4. Okay, then I have f of 2x, which we said was u. If you want to highlight that, you sure can. And then dx, which we said was 1/2 du. Okay, so that is how your answer would look in a multiple choice. Let's try another one like that. How about this guy, the integral from, let's write x equals 1 to x equals 3 of g of x squared times x dx. Okay, once you have that written down, decide what you want u to be. Should we let u be the baby again? Let's let u be x squared. Then du would be 2x dx, right? Okay, once again, I just have an x dx, but that's not a problem. Let's just multiply both sides by 1/2 again. Okay, so let's come and rewrite the integral now in terms of u. So the integral, when x is 1, u is also 1, right? 1 squared is 1. But when x is 3, u is actually 9. Okay, then I have g of u now, because x squared is u, and then x dx is 1/2 du. Okay, and that would be your answer. Okay. That is all I have for this section. Let's go ahead and look at your AP Set 5B, which I believe is due tomorrow. So it tells you in part, well, it tells you that g of 2, sorry, it gives you g of x, doesn't it? It says that g of x is the integral from 1 to x of f of t dt. Okay. So if I wanted to find, like in part A, it asked me to find g of 2. right? Well, that just means you're going to replace all your x's with 2's. And this symbol just means find the area under the curve, right? So if I want g of 2, that's going to be the integral from 1 to 2 of f of t dt. So you're simply going to find the area under the curve of f of t from t equals 1 to t equals 2. That's it. Okay, so look at the graph of f, go from 1 to 2, and find your area using your basic geometric shapes. All right, let's see if I can. Nope. Move that. Okay, so then I think it asks some questions, some increasing, decreasing, maybe concavity questions. So I just want to go over it with you. If I take the derivative of the left side, I get g prime of x, right? We're going to go over this more later, but just kind of intuitively go over. If I take the derivative of an integral, I'm going to get the original back, right? Because an integral involves an antiderivative. Okay, and we'll go through the theory more later, but just so you know that g prime of x is going to be equal to f of x. Okay, so the graph that you're given is actually the graph of g prime. All right, so where it says graph of f, right there, would you put equal to g prime right under the graph? Okay, so if I want to find g prime of -3, for example, that would be equal to f of -3, right? So you'd go to your graph, find x equals -3, and tell me what the y value is there. If I wanted to find g prime of -3, sorry, g double prime of -3, then that would be equal to f single prime of -3. So go to x equals -3, find the slope there, right? Should be linear there, or a sharp corner, and tell me what you get there. All right, so just some hints for 5B. Hopefully those will help. And that is it for section 4.5C. I will see you all next time.